Everyone, and welcome back to A View from Earth, the official podcast of Fisk Planetarium. As always, my name is Tara. I am a planetary scientist and a CU alum. I used to be a presenter at the Fisk Planetarium as well as the outreach coordinator. I no longer get to do that, and it is very sad, but I still get to come on and host this podcast with my co-host, Colin. Hi, Colin.
Hello. Funny thing that just happened, my internet did just die fully and both of you froze and I heard none of that right as that happened, which is funny. And so
it's fine. You know who I am.
I do know who you are. I know a lot about you, I think, unless you live like this secret double life that, I wouldn't be surprised to find out if Tara Tomlinson was actually like a spy. I mean, you speak Russian, so like there is that, Sorry. I'm going to blow your cover. Anywho, hello. Yes. Hi, I'm Colin. I also, I don't know what you said, but I'm going to go ahead and think that you said the following, which is that I also work at Fisk. Currently, as a presenter, I'm a student here at CU. I study astrophysics and computer science. And I will hopefully graduate in the spring if all goes to plan. But that's kind of what I do and who I am. And I also have internet issues, apparently. So that's me. Thank you for coming. John, hello.
Hi, I'm back.
Yay!
Yeah. I was away for season 4, but I'm back now. And yeah, in case anybody has not known me, I graduated from CU back in 2019, and now I work in their production studio, doing a lot of the, productions, building full dome shows and other kinds of content that we put up on YouTube and this podcast as well. So yeah, that's who I am.
And because you just heard John talk so much, that must mean that this is another A View from Earth holiday special.
Yes, it is.
It's not a typical 2-person or 1-person interview show like we normally do. This is our world famous holiday specials that everyone knows and loves.
World famous. Wow.
Yes, totally. And unfortunately, this is the last holiday special that we will be doing. A View from Earth has sort of run its course, and we are all moving on to bigger and better things. And we'll talk about that a little bit later, what exactly is going to happen in the future. But to start off, we thought we would take a look back at some of the things that we've done and the places we've been and the people we've talked to. So Colin went and pulled some clips from each of the highest viewed shows from each of our 4 seasons. 4. And so we're going to take a look at some of those and some of the cool people that we've talked to. So we're going to go all the way back to season 1, episode 1, our very first one, where we talked to, so we had an episode 0 where we talked to John Keller, and that was great too. But season 1, episode 1, here's a clip where we talked to Jimmy Negus about active galactic nuclei and black holes at the center of galaxies. Just to clarify, so do most scientists now think that every galaxy has a black hole at the center?
Every massive galaxy. So the exception, of course, you have dwarf galaxies or irregular galaxies. So you can think of objects like the small Magellanic Clouds, the large Magellanic Clouds. For objects like those, it has not been confirmed that at the center of all of those entities, there exists a black hole. But what has shown in the literature with very, very strong consistency and evidence is that supermassive black holes do occupy these inner regions. And, of course, it's astronomy, so we can only provide the strongest consensus. It's a scientific process, so it's always under constant review and evaluation. And so that's why nothing is 100% definitive, but we strongly believe that this is the case for our massive galaxies in our universe.
So that was Jimmy Negus telling us about the fact that all large galaxies, as far as we can tell, have active galactic nuclei, aka black hole at the center.
And I think it was, yes. I think he made another really good point there, though, that science is not 100%, especially astronomy. It's like we never know something for sure without a doubt. There's always, we're doing the best we can with what we have. And I think that people need to remember that. We're doing the best we can.
Yeah.
She says as she starts crying. Yeah, I think, having been a student of natural sciences in college, which is, something that I was interested in, but not like enveloped in high school and before, I think that there's a lot of missing, at least for me, there seems to have been a lot of missing information about what science as an institution is, right? I was kind of under the impression that, like, contrary to what Jimmy told us and what you just emphasized, Tara, that like science was in the business of finding things that are absolutely true. And I think that you'll meet very few scientists, if any, that will claim that, rather than what Jimmy said, which is that we're, trying to get as close as we can to the truth in understanding the way that things work. But like all we can do is our best. And the other point that I think is often missed is how much science, and perhaps this has shown up on our show before, how much incentive there is to prove things wrong. And that's really important because, and it often gets skipped. That's important because what it means is that the things that survive are the things that cannot or have not yet been proven wrong by fellow scientists. And there's a huge incentive to do that. You gain a lot of credibility and brownie points in the scientific community if you can show that someone's paper has a flaw. And that's why you can trust what we have so far, is because it's very difficult or impossible with the data that exists to like show that certain things aren't what we think they are.
Yeah, and I think going back to your first point and Tara's as well, I think the idea that science always has an answer is sort of comes from the way, at least in the American education system, how science is taught in elementary school, high school, and even the first couple of years of college, is that there is always a right answer. You have a test and you find the answer and then you're done. Because you're looking over discoveries that have already been made. They've already been, they have not yet been disproven, as you said, because for the most part, we've found that they are correct. But then you get into the last 3 or 4 years of bachelor education, and you get that realization hit very hard that there's a lot we still don't know.
I know I struggled with that when I first started doing research.
Yeah.
It was very much like I felt terrible because I didn't know the answer. I could not figure this stuff out. I spent 3 years on this project and have like not really a conclusion.
Yeah.
But it's definitely a disservice to people to bring them up that way. But it's something that we learn.
Yeah.
You roll with it.
Absolutely.
I think having that understanding of what science is too also helps to kind of, I don't know what the right word is here, but like it makes it okay when we find out something new and what we think is true changes. For example, for hundreds of years, I think it's probably hundreds, it could have been thousands, people thought that planets were on these little like mini orbits on orbits called epicycles, and that the Earth was the center of the universe, right? And this was, I think that Ptolemy, a Greek astronomer more or less, was perhaps the most like well-known characterizer of this. And, it took a long time for us to realize, wait, there's a much simpler explanation that makes so much more sense. And that's that the sun is at the center of our solar system and things orbit the sun. And that's the, generally referred to as the Copernican view, right? Copernicus was the astronomer that kind of coined this idea. And it was the fact that, like people really thought that epicycles were a thing. Like that was how it was thought to be. And people had to be receptive. And at first they won't, they weren't. It was a kind of a pushback to say, no, like we're not the center of the universe. But over time, scientists and kind of the literature and the idea of what was adapted to the better explanation. And so it's important, I think, that we also don't resist new information that can, change the way that we see things.
I will take this moment to plug this amazing book called The Structure of Scientific Revolutions by Thomas Kuhn. That goes into all of that from all the way from like way back in the Greeks up to Einstein and modern quantum stuff. And it's really fascinating. It's written sort of from like, he was a physicist, but also a psychologist kind of, or maybe like a philosopher perhaps, but it's really, really good. And I highly recommend that if you're interested in the thought process behind science. Really good
That's
stuff.
sick. Thanks for that, Tara. I might have to go check out myself a copy of that because
Really
that's
good.
super cool. All right.
Well, shall we move on to season 2?
Yeah, let's move on.
Okay. Well, for season 2, our most watched episode was with Andrew Novick, where we talked about the atomic clock. What makes the atomic clock tick?
Can you give us kind of a brief overview of what an atomic clock is and kind of how it works?
Yeah, sure. So atomic clocks work with a natural resonance frequency of atoms. And the huge benefit of atomic clocks is because before, whether we used pendulum clocks or quartz crystal clocks, or even the stars and the planetary motion for figuring out time and time synchronization, all of those factors have kind of a human aspect to them. So like if you made a quartz crystal clock, the frequency of that clock depends on how you cut the quartz and the temperature and things like that. Or the pendulum, the frequency of the pendulum depends on the length of the arm. And so if you were to make a clock, a pendulum clock, and I were to make a pendulum clock, there's nothing that would say that those would be the same. And so using a natural resonance frequency of atoms, we have a huge benefit that anywhere around the world, the resonance frequency of a particular state change of a cesium atom is the same frequency. And so the way that we get that frequency out of an atom is not that the atom is emitting a frequency, in this case, it's that a very particular resonance frequency will make an atom change atomic states. So if we want to change between the F3 to the F4 state of an atom, if you remember your orbital chemistry, there's a very particular frequency so that if you interrogate the atom with that frequency, it will change states. And so what we do is generate a frequency at or around the frequency that we believe will make an atom change state. And we do it to a lot of atoms. So in the case of like a cesium beam tube clock, there's billions of atoms streaming by, and they go through a region where they get interrogated with a frequency, and then we look on the other end to see did they change state or how many change states. And then we use a feedback electronics to change the frequency to where we get the peak of atoms changing state. And so that frequency is kind of locked to that resonance frequency of atoms. And usually that frequency comes from, even though like the resonance frequency for cesium that we use is on the order of 9 gigahertz, 9 billion hertz, but that's multiplied up from like a 5 or 10 megahertz signal. And so what we end up having is a really, really stable 5 megahertz that comes out of an atomic clock. Because it's locked to that frequency, that resonance frequency. So you might wonder if it's not really an atomic clock if it doesn't tell what time it is. It's really an atomic oscillator. The output of an atomic clock is not time, it's actually frequency. It's a very, very, very stable frequency.
And that is our interview with Andrew Novick, or part of it.
That was a lot of big words and concepts.
Yes, it was. Absolutely. I wonder if now we're at this crossroads. Do we try and dissect some of this right here, right now? Or do we encourage any listeners that are curious about what all of this was to go listen to? Because I think we do break apart a lot of what Andrew just said, following that question.
Yeah. I think so
perhaps you can go check out season 2, episode 13 of A View from Earth for the full walkthrough of what's happening there.
He will explain it much better than I ever could.
Yes. Yeah. I mean, that's his job. So,
Literally.
I mean, I think the basic point is that when you have an atomic clock, just like you have an oscillating clock, it's that back and forth motion. Even that doesn't measure time. That just gives you the interval of a second. And so when you have that 5 megahertz signal, every 5,000 cycles of that, you've passed 1 second.
Right.
And so that's how you keep track of that kind of time.
Right.
That was an excellent, succinct description. Thank you, John.
John Schiller, everyone, atomic clock specialist.
Oh, please don't say that. I still don't really understand most of it. That's what I gleaned from that portion.
Well, I think you've done a great job at it.
Thank you.
I think also something, and perhaps we talk about this in the episode, but I'm not certain, is how you go from having that really, stable cadence. Now we really understand, like, here's a second, right? And we kind of defined, like, we chose cesium, and we talked about why we chose cesium as the atom that kind of helps us define the second, and how you kind of take that and like turn it into, here's the time that the world uses, which is, despite his example of using the stars as kind of like a human interpretation of what's happening, I think that we actually do a lot of reference to astronomical, mechanics in saying, hey, midnight or noon is defined by the average position where the sun is highest in the sky over this region, and that's noon. And then we, midnight's the opposite, et cetera. Things like this. So,
well, I mean, that makes sense, because like our definition of certain amounts of time comes from astronomical events. Right. Our definition of a year is the amount of time it takes for the Earth to orbit the sun. And so logically, you follow that progression down step by step till you get to more instantaneous measures of time. Maybe not instantaneous, but like you break it down further and further, and exactly until you get to the atomic measurements. Yeah.
Right. Which I mean by cannot be broken down further. I realize that can be confusing because we're referring to an atom, and it means the same. Wow, look at that! All of these things mean the same thing. Anyway, I wonder if that means something interesting too. Like if we have found, hey, if we can use the cesium atom to define a second, which is a unit of time that's existed long before we could measure the oscillations of a cesium atom, like is there something, connected between a cesium atom and its oscillation to a base 60 framework of time that we use to break our days, which are astronomically defined? I don't know, kind of crazy.
Yeah.
All connected, man.
It's all connected. I think they chose cesium because that's one that broke down easily into that base 60. If there was another civilization that used a base like 35 time scale, then they would choose another atom that fit into that period.
Do you remember when, I want to say it was like some French institution wanted to change our time scales to base 10? So there would be like 10, what was it? It was like 100 minutes in an hour and 100 seconds in a minute, and then like 10 hours in a day or something like that. And there was like the math to support it, but the rest of the world was not using that system. So
yeah,
that would have been really nice. I wouldn't have to write a program to like do time conversion to like stack durations.
Yeah.
Crazy.
Yeah, that's always the hurdle when you want to switch units on a national or global scale, is just getting everybody on board and doing it. The system you come up with may be better, but there's so much process involved in switching over that it becomes easier to use the old system.
There is now, it used to be we could just go in somewhere and say, this is what we're using now, use it or not. And now, it's a little more diplomatic, which is a good thing. That's a good thing, I would say.
Yeah.
Cool.
Speaking of diplomats, this is a perfect segue into our next clip from season 3. Our most watched episode was Washington Ad Astra, where we talked about space policy with Dr. Jack Burns. I loved this episode. I loved this conversation. I thought it was really cool, and we could have talked to him for like days. But here's just a short little intro to that.
So one of the first things we wanted to ask you is this idea of space policy. Has this always been something that interests you, or is this something that came with your experience of doing science?
Yeah, it really came with doing science over the years. Spending a lot of time in Washington, advocating for missions, advocating as part of the American Astronomical Society for funding for astronomy and astrophysics, getting to know the movers and shakers on Capitol Hill, a number of administrators of NASA over the years. So you sort of build up a little bit of that expertise, actually a lot of that expertise over a period of decades, seeing how Washington works, seeing how to get things done. And then when I rejoined the faculty at CU after serving as a vice president for academic affairs and research, I started teaching a class on space policy almost 15 years ago now. So, and do that pretty regularly. So that too, teaching always further develops some expertise.
And there you have it.
I will agree with that point wholeheartedly. Teaching always helps develop some expertise.
Absolutely.
I used to make that joke with my friend who's a math professor. And she would be really worried about scheduling her entire semester at the beginning. And I was like, no, you just need to be like 2 lessons ahead of the students, and then you're good.
I did work with a professor here at CU for a summer and like a semester, who also felt the fears of like knowing, what am I going to teach? And the thing is that it's apparently every so often as a college professor, you are asked to teach a subject that you don't specialize in, that you don't have experience in. And so he was teaching himself the material, moments before he had to teach it to a class. But it's kind of cool because, something that I've heard a lot over, the kind of academic life cycle is that getting your degrees is, a way of specializing in what you do, but even more so, it's learning how to learn and becoming really good at learning. So these, professors, of course, are well equipped to learn something quickly and then, redistribute that information understandably. But teaching adds a lot of perspective for sure.
Sure. And I even did that with some presentations when I started doing the seasonal specials with the solstices and the equinoxes and things. Like before each one of those, I did so much research and learned so much cool stuff about solstices and equinoxes that I had no idea. A lot of weird cultural things and just trying to learn how to explain things better. You got to do a really deep dive sometimes. So just preparing for shows that I would do, I would learn a ton.
You also kind of learn a lot about what you don't know. I, for several semesters here at CU, have been a learning assistant, which is like, for anyone who doesn't know, an undergraduate TA, more or less. And there's a lot of times where leading recitations and things, a student would ask, why is this the case? And if that question hadn't been asked, it wouldn't have bothered me, I'm okay with whatever gap there was. But as soon as the student asks the question, you kind of have to be like, wait, why is it that way? And you kind of have to work through it with the student and figure it out. And there were a couple of days when we had to leave and say, let me go look into this, because I can't answer that right now. And you end up learning something really cool.
Yeah. And that happens often at the planetarium as well. You'll be giving a show and you'll get an audience question about, why does this happen? What does this, or what is this thing that we're looking at? And you're standing there and you don't know. And so I had presenters often say, I don't know the answer to that. Come talk to me at the end of the show and we'll figure it out. And then as the navigator, I'm sitting back there. I end up just Googling it and looking through all the information. And then, bring that to the audience member. Or sometimes even we can't find the answer, and we give them take their email and say, we'll do some more research and we'll send you the answer.
That was always my go-to when I didn't know. I would turn around and say, John, do you have any idea? Synchrotron radiation. Oh, okay, yeah.
Obviously.
Yes.
And that's kind of a cool thing about coming to a live planetarium, right? Where you have these people, even if the presenter in the room, and our presenters generally are, they have the job because they're passionate about, space and space facts and, explanation and things like this. But we also have connections as a planetarium to the entire astrophysical and planetary sciences faculty at CU. I have phoned in Dave Brain several times to answer questions about Mars, for example, that I couldn't find the answer to myself. And that's kind of a cool resource because, you can't generally, like on YouTube, if you're watching something, say, hey, can I get in touch with an actual expert who has a PhD in this field? But at FISC, that is true. And so it's kind of a cool they're just a phone call away.
Absolutely.
Sometimes or a Slack message.
But yeah, they're contactable.
And also on the subject of space policy, which really is what that episode is about. And it's a newer field that we've kind of had this habit of telling people how and what is okay in society and how to do things. And I think only recently, which is something that we touch on the episode, has there become the advent of space travel and saying, well, can you, when you're done with your spacecraft, can you just leave it up there? Or do you have to control where it comes down? Or can you just forget about it? How does this all work? And that's something that a former roommate of mine is super interested in, going into as well. So if you're interested in policy, but, not loving doing quantum mechanics, then perhaps that's an avenue for you.
Yeah,
definitely. Well, we've got one more season and one more episode here. Our season 4 most watched episode was one of the first ones. It was Doing the Wave, where we did a double interview with Lynn Harvey and Cora Randall. That was a nice wave, Colin. I like it.
Thank you.
That was really fun to talk to both of them. Let's see what they had to say.
Wave is investigating gravity waves, which are different from gravitational waves, which we normally think of with things like, black holes and big astrophysical objects. So what exactly are gravity waves and how do they differ from these gravitational waves, or how do these gravity waves work?
So gravity waves, as we are investigating them, they are formed in the Earth's atmosphere. So whereas the gravitational waves you're talking about are extraterrestrial, the gravity waves that we're talking about are actually generated in the Earth's atmosphere. A lot of them are generated near the surface by weather phenomena. For instance, a thunderstorm might generate gravity waves, or a hurricane might generate gravity waves, or just very fast winds that come over the mountains might generate gravity waves. And then they're called gravity waves because the air maybe is, uplifted and then pulled back down by gravity, but it's pulled a little too far. So then it goes back up again to compensate, and then it goes back down again because of gravity. And so it forms this wave-like structure in the atmosphere. Those waves, even if they're generated way down low near the surface, they can actually then travel up through the atmosphere. And because it's a wave, it will cause variations in the atmosphere itself. It'll say the density of the atmosphere will then take on this wave-like characteristic, or anything in the atmosphere. The temperature will take on a wave-like characteristic, or say ozone in the stratosphere will take on a wave-like characteristic. And these can propagate all the way up through the upper atmosphere into the ionosphere. And because they cause variations, and we need the ionosphere to help with communication, say with satellites, GPS communication, they can actually then affect those communications. So that's kind of it in a nutshell, I would say.
We didn't quite get there in that clip, but something that I notice all the time now are clouds, which are caused by gravity waves. And you see those clouds that there's a line of cloud and then nothing, then a line of cloud and then nothing, and a line of cloud. and you just see these like lines. Those are gravity waves. You're seeing that happen in action, forming cloud structures, which is something that I never realized that was like a thing that happened. And now every time I'm outside and I see one of those clouds, which they're pretty common, especially over the mountains here in Colorado, you can see them. It's kind of crazy.
We do not get them over the mountains in Vermont. It's a whole different system. Like the clouds, the sky and the clouds here are completely different than they were in Colorado, even though it's still sort of mountain, maybe because I'm like in the middle of the mountains instead of on the foothills and right on the edge. But still, it's weird.
Qualitatively, like describe, like in what ways are they different? What do you see over there in Vermont?
They are fast. Like we don't have nice, just like, you know how sometimes in Colorado you get those like big, like the big super fluffy clouds or lenticular clouds that just sort of like hover and they're just there. Clouds here race, man. They are quick. I don't know if it's because we're so close to the ocean, if that has something to do with it. I'm not an atmospheric scientist. I don't know. Let's call Dave Brain. But it's very strange. We don't get a lot of like big thunderhead kind of clouds. We don't get lenticular clouds, which I'm pretty upset about. Those are my favorite. But yeah, it's just like it's just very different. It's strange.
Crazy.
Yeah.
Totally. It's like a whole other place.
It is. It's like you're not even in Colorado anymore.
I know.
Bizarre.
Yeah, but I mean, I grew up in the mountains of Colorado, and I can confirm that we rarely got gravity wave clouds because the air was just so broken up by everything on the ground. Then when I moved out to Boulder, I see them all the time out here. And so I think it's that really like sharp edge to the mountains that we have that creates that ripple.
If you've never had the opportunity to look at a topographic map of Boulder, listeners, it's a crazy, like it's flat, boom, mountains. It's not progressive at all. Like there's like a line that you can draw and you're like, that's where the plate came up. It's right there. And that's that, which is kind of bizarre.
Yeah.
It's a unique place.
Mm-hmm.
It really is. And we also get some of the highest winds in the continental United States here. Yeah.
73 miles an hour 2 days ago.
Yep. Yeah, it was crazy.
Full-grown pine trees out of the ground.
Yep.
We had a windstorm here and we had gusts of like 50.
Oh, wow.
It was crazy. I know. that's a normal day in Boulder, but it blew over our wood pile.
John's oh wow, completely sarcastic. Wow.
Oh
yeah.
Wow.
That's a lot. Yeah.
I know. Jaded me over here, which is like, this ain't windy.
Which is interesting because the clouds are fast where you are, but the wind is generally less, it seems in magnitude less crazy. And here in Boulder, there's lots of wind all the time. That's pretty serious. But the clouds are like, nah, bro, I'll just hang out here. It's fine.
I wonder if the wind is coming like over the top of the mountains and just going high and pushing the clouds with it.
Ooh.
Yeah.
I could see like if you have a range of mountains and you have a weather system moving, right? The air would kind of go up like a ramp off the mountains into the clouds, do some stuff. And so if you're in the mountains and the wind's coming up the mountain on one end, then that would make sense. Whereas in Boulder, it's all of that air coming back down the mountains, kind of pointing it straight at the ground where everyone is.
Yeah.
So, non-atmospheric science, that your idea there makes sense with the very zero atmospheric authority that I have.
That any of us have.
Yeah.
Hey, I took a class in atmospheric science.
I did too, but it was from a non-atmospheric scientist.
I didn't.
Not true.
So I should shut my mouth.
I took one ATOC class.
I just took the one we do in APS, but it was great. It was awesome.
Planets in their atmospheres.
Planets in their atmospheres.
I almost took
class.
that course for the spring, but opted for spectroscopy instead.
Yeah.
Let's look at some spectra. Wow. Those were our top viewed episodes from each season. And actually, as it happens, that first one with Jimmy, and also we speak to Andrew Hamilton after we speak to Jimmy in that episode, is our number one viewed episode of all time. So kind of a fun start to the podcast. And then we slowly tapered out and the show became one of the that for those who are always around listening. So thank you for those listeners that are still checking us out.
Okay, so we've looked back at some of the things that we've done on A View from Earth, and in our holiday special tradition, we are going to now look forward. And, we thought we'd start by looking at the future of the three of us and what we're doing now as opposed to last year and where we think we're going to go in the future.
I love that.
Who wants to go first?
Episode constitutes a tradition in our tradition, which we've done once, and that's beautiful.
I think it's a great tradition.
Okay, great. Cool. Yeah. Yes, John, I agree. It is a great tradition. And here I will uphold it right now. And here we go. I'm so sorry. In the future, I plan to be no more smooth than I am right now, which is not very much.
You're well on your way.
Wow. Listen here, Tara. Let's think. So as I mentioned earlier, I plan to graduate in May, barring any complications that would make that not the case, such as failing classes, which I don't plan on doing. And so if I graduate, when I graduate in the summer, I will do the normal things that I do, which is musicals. I'm a music director for a couple of local educational youth theater companies. We do like summer camp shows. So that'll be the first part of my summer, regardless of what happens. And I actually recently applied for a position at NCAR to work on some data visualization design. So like, a team or a scientist comes and says, I have this data set, make it look like something. And then we do. And so hopefully if that happens, that could potentially turn into a job full-time after I graduate, which would be sick because, staying in science and getting to just make cool plots and visualizations sounds sick to me. If that's not the case, I really am interested in computer science and data analysis, which kind of go hand in hand, but I'll search for something there. And then perhaps one day I'll go back and hopefully maybe find a company that will sponsor like a master's degree or something and, go back to school, because school is all I have known for the past 21 years. And it's a lot of fun. So there's what I see as my future in a nutshell. Popcorn John.
Yeah, so I'm still at Fisk. I plan to be for at least the next little while. I've been loving doing the production and exploring my creativity. That's not something I've ever really had a hand in. I've always been very in very technical fields, business operations into hard science. So I've been really enjoying exploring my creativity and being able to do that. Long term, I think I might go back to school. I've been looking at a couple engineering master's programs, either mechanical or aerospace. So yeah, kind of just going with the flow right now and seeing what the future holds for me. Popcorn Tara.
Hey, so I guess since last year, my big thing was I have started grad school now. I am in an engineering program at Dartmouth. So I am no longer in Colorado. I am up in beautiful Post Mills, Vermont, population 213. But I am going to school at Dartmouth. I am in their engineering school, which is a huge change for me. I come from totally astronomy, planetary science background. So being an engineer now is a whole other world. It's very, very different, but I'm still doing planetary science. I'm just doing it sort of on a different scale and from a different point of view. But I get to do really cool things like look at glaciers on Pluto is one of my projects that I'm working on. I'm also doing some stuff with like how salt and water and ice interact in the shell of Europa, testing different kinds of interactions that are happening and seeing, where brine channels form and go, and there's thermal stuff. It's making plots. It's awesome. So that's some really fun stuff that I've started working on. I've still got some classes that I have to take and things like that. So that's basically the next 6 years of my life is just doing this this grad school thing and learning to be a professional scientist in a whole sort of other capacity. I've been doing science for a living for a few years, but this is a whole other ball game. So I've also just started working as a advocate for the International Dark Sky Association, which is really, really fun. We have great meetings, and I got to see a really cool presentation about the horrors of satellite constellations. Don't get me started. It's craziness. But
Tell us about satellite constellations, Tara.
What's that?
Tell us about satellite constellations.
So like satellite constellations, people, if you're not familiar, this are the things that like Elon Musk wants to send up into space to give everybody free internet. That's a great idea, but they're launching 65,000 satellites in the next like year. So, and they're all going into low Earth orbit, like right where the ISS is, right where all of our Earth observing satellites are. So, and it's just filling up the sky with space junk. It's causing light pollution. It's endangering our astronauts. It actually causes air pollution too, because when these things get to the end of their life, they fall back into the atmosphere, they burn up, they release a ton of aluminum into our atmosphere. So there's that. It's pretty frightening. Anyway, that's a thing I'm doing too, is being a dark sky advocate to bring about awareness to light pollution issues, both on the Elon Musk level and on your neighborhood level. Fix your lights, turn your lights off, that kind of thing.
People, I think, don't realize how much more night sky there is if you grow up in a densely populated or even like a mid-tier populated area. One of my favorite things to do in Star Talks at Fisk is to, we like make it nighttime if it's not already nighttime, keeping light pollution on, and you can see like, the 1,000 brightest stars or whatever. It's pretty similar to what you would actually see outside. That's the point. And then we say, okay, what if we took a drive up the canyon and went to like a place that's not heavily, populated and there's not so much light, and the navigator like slowly, dials back the light pollution and like tens of thousands of stars pop into view and you're like, oh my God, I can see everything. And it's people like every time there was an audible ooh or ah, every time.
It's the absolute best.
It's the best. And so if you haven't experienced that, do somehow, whether that means going to Fisk and seeing one of these Star Talks, which accompany pretty much every show that has a live presentation, or if you want to just like go see a place with dark skies, there's websites that will show you where. It's really something magnificent. So
that's one of the things that really got me to want to be an advocate, is moving out here to the middle of nowhere, way out in the country. And I can see the Milky Way from my porch. Like, and my neighbors have lights on, and I can still just look up and hey, there it is. It's craziness. Like, it should be like that everywhere. Everywhere should be that way.
I think it's easy to forget, those astronomy plays such a huge role in what, like in human culture everywhere. And I think that, sometimes it's easy to understand why that is the case when you don't have light pollution. The night sky is so in your face. It's so beautiful and striking. And then when you have light pollution, it kind of goes away. And you like living and having always lived in a at least somewhat populated area, I'm so used to the night sky mostly just being like this like dark haze, even in a clear night, there's just not much going on. And so, well, thanks for being an advocate for dark skies, Tara, and helping us.
And it goes way beyond astronomy too. It's a social justice issue. There's a whole lot of really disturbing research that's going on there. Like, it's animal rights. Like, we're messing up bird migrations. Birds are dying by the thousands, from all of this different stuff. So it encompasses a whole, like, it increases rates of cancer. I just read a report that it is tied to worse cases of COVID, like things like that. It's a whole encompassing thing. It's not just an astronomer's problem. It's not just we can't see stars. It's way bigger than that.
Nice. Well, is there a website that you can point listeners to that if they want to go find this out?
Yes. I believe, let me double check. darksky.org is the IDA website. And anybody can be a dark sky advocate. You just got to fill out a thing and come to a 1-hour training session. And boom, you're an advocate. Most places have local chapters that do like meetings and things. Colorado has a really big one. There's not one up here, so that might be in my future too, is starting an IDA chapter for the Upper Valley.
Nice.
We'll see. With all my free time.
Yeah, you know, you're not busy at all. It's fine. So cool. Well, I guess moving ahead. So if you've been on the campus of CU, taken an astronomy course here, or, you know, there's a handful of these elsewhere in the US and probably around the world, we have something called the Colorado Scale Model Solar System, the CSM-SS. And it is essentially, we took this solar system, divided everything by 10 billion and put it on our campus. So there's a sun, and then there's, you know, right now, actually, no, it's been updated, and we have a guest to tell you about that in just a moment. But it allows you to walk through the solar system and see the relative sizes and distances of everything. So there's plaques, right? There's one for the sun, and then Mercury, Venus, Earth, Mars, and the asteroid belt, and then you skip through and you get Jupiter, Saturn, Uranus, Neptune, still Pluto. And you can kind of see just how, you know, how these sizes relate and how small and how little space the planets take up, you know, in the grand scheme of things. And how they compare to the size of the sun, for example, how much larger the sun is than the planets. It's very cool. But actually, there was just a pretty serious update to that thing on our campus. And so for that, we are going to talk to Jimmy Negus, who you actually heard just moments ago from our first episode and that little recap. And I'll let him do some of this talking. All right. And now we are speaking with Jimmy Negus. Jimmy, thanks so much for being with us. Tell us about the Colorado Scale Model Solar System on CU's campus and what role you're playing in what's happening with it.
Oh, cool. So yeah, I'm Jimmy. I'm a 5th-year grad student in the astronomy department. And yeah, the Colorado Scale Model Solar System has been a passion of mine. I've been working on upgrading the existing model for about 3 years. So my role was, you know, I was a TA in the astronomy department, and I saw the model needed some upgrades, and I started a campaign to upgrade the model entirely. And so, yeah, it's been a journey of, you know, funding and garnering interest and getting parties invested, and you know, really having this grand vision of a new, freshly minted model installed on the campus of the University of Colorado at Boulder. And part of those upgrades, you know, we're dealing with stanchions now, which are upright, which are, you know, different than the traditional plaques of the original model. We have, you know, full color graphics. We have
really quick before we get into the details. Yeah. What is the CSM-SS? Just briefly for everyone that doesn't know what it is.
Right. So let's take a few steps back. The original Colorado Scale Model Solar System was first initiated in 1986 under Dr. Jeff Bennett, who was a grad student at CU at the time. And the original model was dedicated to the Challenger space shuttle accident. And in particular, one of the space shuttle disaster astronauts was an alumni of the university. And so this original model was sort of devoted as a memorial to that astronaut, as well as providing sort of an educational resource for the campus in terms of understanding cosmic distances, in particular, our solar system distances.
Cool. Sorry, I just wanted to get that in there really quick so that anyone listening could say, oh, what is this thing? And then, so you've gone on this journey of funding. You noticed it needed some upgrades. from the 80s when it was installed. It's now 2021 for anyone listening way in the future, perhaps. Or
it
for
predates my birth.
Yeah, there you go. Mine too. Yeah.
All of us, right?
All of us. It predates all of us. Yeah. So good. So, okay.
Not all of us.
Sorry.
Calling you out. Yeah.
It's fine. It's fine.
Cool. And so, okay, so now that we're caught up, this is what the scale model solar system is. And you've mentioned it needed some upgrades. You went on this journey of funding. And what did that look like? Was it tricky? Did you have to fight hard, or were people generally like, yeah, this could be upgraded, let's get a new one installed?
No, it's challenging. Anytime you're trying to pry money from any other entity, it's a challenge. The fortune was on our side that this was pre-COVID. So before the real budget restrictions hit, we had this campaign. And it started with, departments. These are the most direct resources we have on campus are the departments. And they use the model in their curricula, and their students engage most directly with the model. So we started with the astronomy department, which, having some ties was the most natural course of action. And, even that wasn't immediate. There's some negotiation. You have to propose, why do we really need to upgrade the entire model? Why couldn't we renovate the model? Are there cheaper options? Have you done your due diligence? What is sort of the return of our investment? And so these are all questions that had to be answered. And, fortunately, we presented what I believe is a compelling case. And we were able to secure, one of our first donations with the astronomy department. And then the next logical step was, well, the aerospace department has links through the fallen astronauts who are alumni of the university who have ties to these departments. And so that was sort of our next step was presenting a proposal to them, as well as other departments. But we realized steadily that, $5-6 grand donations weren't going to really get us to that 12 plus $1,000 goal. And so we had to sort of expand our fundraising campaign field of view. And that's where, the Office of the Chancellor came into play. That's where the Laboratory of Atmospherics and Space Physics came to play. And these were sort of these bigger entities that had much larger funding sources and really helped us achieve our goal. And John Keller, actually, our largest donor is through the Grand Challenge, which is sort of a university entity that helps with seed funding for big projects. And that really bridged the gap near the end with our largest donation. But it's certainly a snowball effect of, first garnering the interest and then seeing what resources are most immediate and then expanding the vision. And once you have a few investors, this is no longer just a cool idea, but it's something that has real momentum, a real vision, and we can present a concrete path forward. And I also want to thank our public donors, even $100 donations through a newspaper article. Like, we want to thank those individuals as well for contributing to the project.
So what were some of the things specifically that needed updating on not just the look of it, but I'm sure there were a lot of scientific things that needed to be updated as well.
Right. So the most obvious was Pluto being a planet, which it's not. It's a dwarf body in the solar system. But there were other sort of not even informations on the plaques, but the literal distances of the plaques. So Mars, for example, had to be relocated many times throughout its existence. And in that process, you're having construction crews that are, where do we put this? Let's just get it on the grass, and not understanding that this is a very sort of precise scientific exhibit. And so we wanted to remeasure, with a very low margin of uncertainty, the precise planetary distances in our scale model, so that when students do these labs, they can get direct correlation with the actual distances of the planets. And of course, even the text was starting to fade. So even inferring what was accurate, the challenge was actually deciphering text, which we wanted to upgrade.
And I understand that along with, more modern visual presentation of all the information, there's also a new way to experience the scale model solar system beyond just looking at the stanchions. Can you tell us about that?
That's right. And this was sort of John Keller, the director of FISC, and Terry Rube from the college media and communications. So they had this great idea to sonify the experience. And what I mean by that is providing sort of an audio aid for members of the public and the student population that are walking the model. And so for us, we considered, what if we have members who are visually impaired or may not be able to make it to the stanchions to read the text? How can they still engage with this exhibit? And part of that is now the new Wanderers app, which is it's available in the Apple App Store. And we're working on a Android version as well. But essentially, your distance to each planetary body is encapsulated by an audio tone. And so, this encapsulates the entire sort of orbital range of each planet. And what this does is this now opens up the model, so it's no longer a linear sort of experience, but wherever you are in relation to the model sun and the closest planetary body, you can get an audio representation of that planet's orbital features and physical parameters. And so this we thought is really cool. It's best experienced with headphones, and it's just an additional layer of excitement for those visiting the model.
I hadn't realized that the planetarium dome was in the asteroid belt from the sun. We were in the dome and doing the demo, and they pulled it up on the screen, and I was like, I've never thought about where we are relative to the sun on this scale. So that was super cool.
Right. It's fascinating. And it's also a reminder, when you see the model, especially for the younger kids, they may think that, these planets are just always perfectly aligned and sweep out their orbit. When in fact, they almost never will you see a perfect alignment of all planetary bodies. And this is sort of a reminder of the spatial sort of orbital context of these bodies.
And then is there one more addition to, so you added Pluto, or you reclassified Pluto as a dwarf planet in this new system. Right. There's the Regent Underpass, which is a bridge on campus that used to not be there as the asteroid belt, right. And that has its own little stanchion now. And then was there also an addition now for the Voyager spacecraft over by the Folsom Field?
That is correct. So there are now sort of two entry/outro stanchions that precede the model sun and that are beyond the model Pluto. And these are sort of our entry boards for accessing the entire model. And one caveat is the entry board near Pluto is extremely special. This is the approximate distance that the Voyager space probe was when it took the pale blue dot photo. And so this is the image of Earth from beyond Pluto's orbit, showing that small little sliver of blue light that is our planet. And that was a profound moment in our history. And so we wanted to encapsulate that with this entry stanchion.
Very cool. What a neat idea for, where do we place this and what does it mean? That's very neat.
Right.
Awesome.
Right.
Is there anything
and I will
else?
say just I just wanted to add one thing. A part of this process is, the logistics and where are we going to put everything and should we change the existing model? And so one idea we were floating with was having, so Pluto's orbital range is very high. Its eccentricity is great. And so we were debating having Pluto actually be closer to the Folsom Field football stadium and being sort of a pillar there and having traffic come to the model. But after much deliberation, we considered sort of the ease of access, particularly for students in labs. And, we decided to keep it in line with the original model. But this is sort of an example of, when you're building something new, these possibilities are all considered, and that all goes into the process of creating a new exhibit.
Absolutely. I imagine it could probably almost be overwhelming, the amount of creative ideas that you could do with this, and you have to kind of shave off everything that isn't, logical or really doable.
Right.
Cool. Well, is there anything else about the renovation or the model solar system itself that you'd like to quickly get in before we move on, or is that the bulk?
I would just like to encourage everyone to come out and visit the model. We're still finalizing sort of the concrete pathways for the inner solar system to make it nice and pretty. But I'd encourage everyone to make it out to our campus and visit the model.
And I understand that the inner solar system will soon be near a park, which is going to replace the whatever is there currently. It's just like like a little bank, and there's some trees and shrubs.
Right.
So
right.
That'll be cool.
That berm is going to be lowered, and a park will then exist. Mm-hmm.
Excellent. A great place to bring your kids then, if you have any. Cool. Well, Jimmy, thanks so much for speaking with us and giving us that quick update on the renovated Colorado scale model solar system that you kind of spearheaded. And thanks for doing that.
Right. No problem.
And we're back. So that was Jimmy Negus telling us about the renovated Colorado scale model solar system. It's kind of a tongue twister. Say that 5 times fast. So come check it out. John shakes his head and says, "No, I don't think I will."
No, I won't, because I know I'll fail.
There you go. Hey, that's what a bad message to send. Don't do things because you'll know you'll fail.
Sometimes you got to set boundaries.
Yeah, well said. Yeah, there you go. Nice. So cool.
Well, there's also lots of. Oh, pardon me.
Yeah, that project is part of the upcoming 50th anniversary of Fisk. Fisk was opened in 1975. So in 2025, we will officially be 50 years old. And the renovation of the scale model solar system is kind of one of the first changes that we're making at Fisk. A lot haven't been publicly announced yet, so there's some things that we can't talk about. But I think it's going to be quite the celebration.
Yeah, so keep an eye on the website and the social medias and things, because we're going to have a lot of cool stuff leading up to the 50th anniversary, which I know like 2025 sounds like a long time from now, but it's only like 3 years from now. Holy cow. This is like, I feel like this is like a NASA mission. Like, we're launching in 3 years. Yeah. That's so soon.
Okay, they've been saying that about James Webb for 30 years. So
that's fair.
Hey,
yeah.
Fingers crossed next week.
Listen,
it was even already, it was the 18th and then the 22nd, and now it's the 24th. So I'll believe the launch when it's in the sky, but it's going to be really cool when it is.
Wouldn't that be a great Christmas present?
It would
Honestly,
be.
Yeah.
Yeah.
Be excellent. Especially because myself and a fellow presenter at Fisk, Rami Morgan, and I are going to do a show about 2021 in review, and we would love to be able to talk about the launch of JWST. So we'll see if we can, or if we can make the same joke we made last year, which is that it's been planned to launch for like the past 10 years, and it's still being planned to launch.
Yeah. And I want to say, astronomers and a lot of the public often joke about the Webb Space Telescope being delayed. A lot of people are working very hard on it, and they're delaying for reasons. It's not just because they don't feel like launching today. This is an incredibly complex project, and it's going out to a place where we won't be able to go and fix it if something breaks. So they want to be absolutely sure that once it gets out there, it can do the job for as long as it possibly can.
It's a great point to make. Yeah, we joke a lot about it, but there's really good reasons why things, are delayed. I mean, astronomers want this thing in space as much as anyone, it's their tool. Yeah. So, I mean, right now we're sitting at roughly $10 billion worth of work on this thing. So it's a huge project, and very important that everyone's absolutely certain about everything that's going to happen before it goes up. So thank you. Yeah, thanks for making that point, John. That's important.
Yeah.
I will also point out that $10 billion that everybody likes to scream about is a pittance compared to what the government spends on other programs. Yeah. NASA gets less than 1% of the annual budget. So 10 billion sounds like a lot.
Of a percent. It's 0.4% of the U.S. federal budget, which is nothing. So,
and that money was spent on Earth. Where it's not that we're taking a large pile of money and shooting it into space. That money has been distributed out to facilities to employ people, and that's my answer when a lot of people asks, shouldn't that money be better spent here on Earth? It is being spent on Earth. We're not taking money and shooting it into space. We're giving people jobs and further advancing human knowledge at the same time.
Well, and something I think, people, there's a lot of, I think a lot of perspectives where, like, why are we, despite that fact, John, why are we paying people to study space? Like, what about everything else that's happening? I think it's easy to forget just how important space, the study of astronomy and space travel both have been to our modern day life. Things like our cell phones, computers that are small enough to be personal, GPS systems, global navigation, things that all of us, kind of rely on and perhaps take for granted as this is just a thing that we use, comes out of space travel and, space science. And so there's a lot of dare I say, trickle down from, space agency technology into, civilian life.
Yeah,
definitely.
Little thing there.
Moving on from that soapbox.
Upcoming
I think we've talked about that in a couple episodes too.
I think we have too.
We have.
If you haven't noticed, it might be a little bit important to space scientists.
We might be passionate about this.
We might be.
But maybe not. Who knows? So, John, tell us about the upcoming productions at FISC.
Yes. So we've got 3 new films that are either have been premiered or are premiering in the next couple weeks to about a month away. The first one is Drifting North into the Polar Night. That one is out now. I actually did a show about it on Thursday, December 20. I recently did a show about it. I was going to say yesterday, but then I remembered that this is not coming out today. We're recording this in the past. That show has been premiered. It is an excellent show. It features the Mosaic Project, which was an icebreaker that went up into the Arctic Circle and got frozen into the ice for a year, with dozens of scientists on board, each measuring all sorts of things about the ice on the polar caps. It's a fantastic show. I highly recommend it. The second show that we're going to be premiering is kind of the sequel to that. Maybe not the sequel, but it goes along with that. It's Drifting North, Arctic Pulse. And that is also about the Mosaic mission. They cover different sides of the expedition. Into the Polar Night gives you more of a broad overview of the Mosaic mission, while Arctic Pulse talks more about the history that led up to it and some of the specific science that they're doing. Arctic Pulse has not premiered yet. That's premiering on January 29th. That's going to be our first showing of it. And then finally, our big film that we've been work on for several years now, called Forward to the Moon. That's the movie that we had Carrie Byron narrate. And through that, she was able to come on this podcast and we were able to interview her. One of the highlights, I think, for all 3 of us of the work we've done on this podcast. That's premiering on February 2nd. We're actually going to have a special event. That's a Wednesday, I believe. So if you want to get tickets to that, I'm not sure when those are going to be available, and I'm not sure how many of those are we going to have. So keep an eye on the website if that's something you want to come to. After that, we'll put that into our regular cycle of shows, and it'll be available probably fairly often because that's a big project we're working on. We're very proud of it, and I think it's going to be a really good movie.
If you've ever seen Capcom Go at FISC, if you liked that kind of show, Forward to the Moon is the next show to see, I think. We saw the trailer, and it's so inspiring. A lot of the stuff that we show is, it's scientific, it's factual, like we're delivering information, and it's very entertaining and informative, But there's something about this idea of like exploration, right? That is so, I think, human. And so Forward to the Moon is going to be a really cool, hype people up to like the next kind of phase of space travel. It's going to be sick.
Absolutely. Yeah.
Cool.
So yeah, those are the shows that we have, or the films that we have coming up. And then we're in production for a couple more. We're still working on getting those funded and starting production. So can't talk too much about those, but we got more coming up. So yeah.
And is it true, John, that films that Fisk produces will ultimately be available in planetariums around the world?
Absolutely. Every film that we produce, all of the content that we produce, not necessarily the stuff that we do for live shows, but anything that we pre-record is available. We release it available for anyone. On our website, colorado.edu/Fisk, we have a production section, and that lists every film that we've made, I think in the past several years. I don't want to be specific about a number of years because I'm not sure.
Sure.
But you can go on there. Sometimes it'll have like the full film that you can just watch right there. If it doesn't, then there's a request form that you can send out. And if you're an educational institution, a planetarium, any scientific facility, you can request these films, and we'll just send you a copy of them. Yeah, we've got a lot of really good content.
Well, thanks, John, for that briefing on our productions goings on.
Yeah.
Very cool that we kind of, to produce your own movies. Like that's sick.
Yeah. Yeah, it's not something I ever kind of imagined I would be doing. As a kid, I always thought, it'd be cool to make movies, but now I'm doing it and it's a lot of fun.
Well, congratulations. That's super cool. And also thanks, because, I think those productions are a big part of what makes Fisk Fisk. So
absolutely. Yeah.
Definitely. And now we will come to the future of the podcast. As we mentioned back at the beginning, this is the last episode of A View from Earth. We have run our course and run out of funding, essentially. But Fisk is not discontinuing podcasts altogether. A View from Earth is sort of morphing into a new and different podcast called SciHArt. Unfortunately, I will not be involved in SciHArt. I will not be the co-host for that. Colin will still be here, but he will also be joined by our friend Nina, who we got to come and tell you a little bit about the SciHArt podcast.
So to kind of introduce how A View from Earth will transform into the next iteration of a Fisk Planetarium podcast, it is my pleasure to introduce Nina, who will be my co-host in this next iteration of the podcast. And so, Nina, hello, welcome.
Hello
to the show. And if you could you introduce yourself briefly and kind of what we're looking at in the future?
Yeah, for sure. So hello out there, everyone. My name is Nina. I've been working with the education outreach team at the Fisk Planetarium for a little over a year now. And soon I'll be working with Colin to bring you a podcast called SciHArt, which stands for Scientists as Hobbyists and Artists. Yeah, so hopefully in the January to February timeline, we're going to start this podcast that's supposed to illuminate the broader humanity of scientists and science adjacent professionals working on like leading edge STEM related contexts. And this whole new podcast is sponsored by something called the Punch mission, which is a NASA Small Explorer mission, call it a SMEX, to better understand how the mass and energy of the sun's corona becomes the solar wind that fills up our entire solar system. So there are over 4,000 different scientists involved in this mission, and we are hoping to illuminate some of their stories in this podcast. different leaders in science and engineering and science communication we're hopefully going to have on the show. And then eventually we're trying to spotlight other NASA missions as we progress. So I'm really looking forward to trying that out with y'all and talking to our captive audience that we've got here.
Absolutely. It's going to be a lot of fun. So SciHArt, and we actually, we kind of attempted some previews of SciHArt style episodes, but that was really before I think Tara and I truly understood what SciHArt was all about. So these were episodes, I'm looking at our SoundCloud right now, episodes 28 and 29. So that's 1-2 Punch of Science and Outreach and Students Studying the Sun with STEM. And they were our interviews with that was Craig DeForest and Mary Hansen, if I remember correctly. And those interviews were a lot of fun, but they were very much a view from Earth style interviews. And so we're going to, perhaps we'll, hear from them again in the future and talk a lot more about, their hobbies and art rather than just, the scientific kind of objectives that they have.
Exactly. Yeah. We're hoping to get a deeper dive, if you will. Yeah.
Which will be
really
cool.
Excited. Tune in the new year.
Perhaps it'll be a nice compliment to, we've spent 4 seasons here talking a lot about the science, and it's kind of a meme when we are putting together our questions for our interviews that our last couple of questions are always very similar, which is, tell us about yourself as a person. How did you get to where you are? What do you enjoy doing outside of the office, etc.? And so SciHArt will kind of turn that on its head, and we're going to focus a lot more on those last couple of questions as the bulk of the episodes. It'll be a lot of fun.
Yeah, great. Thanks. Can't wait, y'all.
Well, Nina, thanks for joining us on this 2021 holiday special. And I'm sure we'll hear from you a lot in the coming months.
That you will. Colin, Tara, thanks so much for having me. Talk to you all later.
So this was our conversation with Nina about the future of the FISC podcast, SciHArt. And we don't have any super rock solid release dates yet. In the coming months, we plan to release roughly an episode a month starting in either January or February is our plan now. But, keep your eyes peeled. And as long as you stay subscribed. Actually, John, this is a question for you. How does this work? Will it be a different show? Will we produce from the same account? What's that look like?
We'll be producing from the same account. We'll be keeping the A View from Earth episodes. We're just going to change the titles a little bit so that we distinguish which show each episode is for. But yeah, if you stay subscribed to the same place you're listening to this on, you'll automatically get those new episodes. So just stay subscribed. If you're not, hit that subscribe button and make sure that you have notifications on so you get updates on when those new episodes are released.
So if you're already subscribed, you don't have to do a thing.
Nope.
We're making
it as easy as we can.
You have to do work to unsubscribe. So just stay subscribed. It's not worth the trouble to go through and
entropy. Just
don't do it
right where you are. Don't do it. Cool. All right, everyone. Well, thanks so much for joining us on this 2021 holiday special of A View from Earth, our final episode. It's been such a pleasure to go on this journey with you all. John, Tara, thanks for being such a great team to work with. And Jeremy, who was our producer for season 4, mostly while John was out. Thank you, Jeremy, also for doing the show with us. And I guess we'll see you on the next episode, the premiere of SciHArt.
Bye.